Download this code from codegive.com, link in the description below. OK, let's dive into the world of beamng.drive settings and how you can tweak them using Lua scripting. This guide will cover various aspects, from basic graphical settings to more advanced physics and vehicle configuration tweaks, all controllable through code. We'll focus on Lua scripting, the language used extensively in beamng.drive for modding and configuration. Understanding the beamng.drive structure and Lua environment. Mod structure beamng.drive mods are typically organized into folders, vehicles, levels, missions, scripts, art, etc. The specific structure depends on the type of mod you're creating, example a new vehicle, a new map, or a script that modifies existing behavior. Lua scripts are often placed within the scripts directory of your mod. They can be further organized into subfolders based on their function, example client, server, AI, UI. Lua environment beamng.drive provides a custom Lua environment. It's not a standard Lua interpreter. It includes beamng-specific libraries and functions for interacting with the game engine. You can execute Lua code through various methods. Console press the key, usually above the tab key, to open the console. You can type Lua code directly into the console and press enter to execute it. This is useful for testing simple commands or debugging. Example, do file, your_mod/script/your_script.lua. *main.lua files Many mods use main.lua files as the entry point for their code. When the game loads a mod, it often looks for a main.lua to execute. Event listeners, callbacks You can register Lua functions to be called when specific events occur in the game, example vehicle spawn, collision, game start. This allows you to react to game events and modify behavior dynamically. Vehicle config files, .pc vehicle config files are written in JSON format, but they can also include Lua code. This is a common way to customize a vehicle's behavior, like its engine parameters, suspension settings, or braking characteristics. Important beamng.drive Lua libraries *Core. This core library provides access to fundamental game functions, like managing entities, vehicles, objects, manipulating the physics engine, and handling game events. Drivetrain, specific to vehicle physics, provides functions for managing engine torque, gearboxes, differentials, and other drivetrain components. Camera, used for controlling the in-game camera. UI, for creating and interacting with user interfaces. Input, managing keyboard, mouse, gamepad input. Settings, accessing and modifying game settings, graphics, audio, etc. AI, controls the game's AI, traffic, chases, etc. Physics, used to interact with the physical physics engine directly. 2. Modifying graphical settings, example, changing resolution. While direct control over all graphic settings via Lua is somewhat limited, you can influence the rendering pipeline and options through renderoptions.json and certain console variables accessible via Lua. Remember, directly setting resolution changes through a script is discouraged, could cause issues for other players. Instead, focus on adjusting details within the user's configured resolution. 1. Accessing settings, indirectly via console variables. beamng.drive exposes certain console variables, CVARs, that influence graphical settings. You can get and set these CVARs using the settings library. Important notes CVARs are not always reliable for persistent changes. Some may be overwritten when the game loads default settings or when the user changes settings in the GUI. CVARs are not well documented. You often have to experiment or look through the game's configuration files to find the names and valid values for specific CVARs. Excessive use of settings. Set can lead to instability. It's generally better to influence graphics through other means, like creating custom materials or adjusting rendering parameters through shader modifications. 2. Custom materials, advanced. A more robust and controlled way to influence graphics is to create custom materials for objects in the game. This involves creating .material.json files that define the properties of surfaces. You can then use Lua to assign these materials to objects. This is a more complex topic, but it allows fine-grained control over how objects are rendered. 3. Physics settings. Physics settings are crucial for modifying how the game behaves. These can be found in various places. 1. Physics.json * located under Documents /beamng.drive /settings. It influences global physics settings. 2. Vehicle.pc files, located in the Vehicle folder under Vehicles / your vehicle. It influences vehicle-specific settings. Here are some examples that adjust physics settings. These settings may or may not be readily adjustable via settings.set. Example: adjusting speed limit from AI*. 4. Vehicle configuration, vehicle.pc files. The vehicle configuration files, .pc files, are the primary way to customize vehicles in beamng.drive. These files are in JSON format and contain a large amount of data that describes the vehicle's parts, properties, and behavior. Example: vehicle configuration script. To ensure that the changes are implemented correctly, create a Lua file in your desired mods folder directory. VAI control. beamng.drive allows you to control the AI through Lua scripting. You can spawn AI vehicles, set their routes, and control their behavior. 6. Important considerations and best practices. Experimentation is key. beamng.drive is a complex game engine. Don't be afraid to experiment with different settings and code to see what works. Back up your files before making any changes, especially to vehicle configuration files. Create backups. This will save you a lot of headaches if something goes wrong. Use the beamng.drive wiki. The beamng.drive wiki, if still maintained, can be a valuable resource for finding information about Lua functions and configuration options. Read other mods. Examine the code of existing mods to learn how they accomplish specific tasks. Use the in-game console for debugging. The console is your best friend for testing code snippets and checking error messages. Use print statements liberally to debug your code. Start small and build up. Don't try to change everything at once. Start with small, manageable changes and gradually increase the complexity of your code. Performance. Be mindful of the performance impact of your changes. Excessive use of scripting or complex physics simulations can negatively impact the game's frame rate. This is a comprehensive overview of how you can use Lua to change settings in beamng.drive. Remember that modding can be a complex process. But with patience and a willingness to experiment, you can create some awesome modifications for this game. Good luck! Okay, let's dive deep into beamng.drive settings and explore how you can modify them using Lua code, giving you greater control over your simulation experience. This will be a comprehensive guide covering various settings, methods for accessing and changing them, and practical code examples. Understanding beamng.drive settings. beamng.drive offers a vast array of configurable settings. These control everything from graphics quality and physics parameters to AI behavior and input mappings. They're typically accessed and modified through the game's UI, but scripting with Lua provides programmatic access for automation, modding, and advanced customization. A types of settings asterisk. Asterisk graphics settings asterisk impact the visual fidelity and performance. Examples include resolution, anti-aliasing, shadow quality, and texture detail. Asterisk physics settings asterisk govern the simulation's accuracy and behavior, like solver type, step size, and collision settings. Asterisk gameplay settings asterisk affect the user experience, such as camera modes, driving assists, and damage models. Asterisk AI settings asterisk influence the behavior of AI vehicles, including aggression, pathfinding, and traffic density. Asterisk input bindings asterisk define the mapping of keyboard keys, controller buttons, and other input devices to game actions. Asterisk audio settings asterisk control volume levels, audio devices, and spatial sound effects. B. Where settings are stored asterisk asterisk. beamng.drive settings are stored in various files and configurations, depending on the setting type. Here's a general overview. Asterisk settings.json asterisk a primary configuration file located in your beamng.drive user folder. This file holds many persistent settings, including graphics, audio, and gameplay preferences. The location of this folder varies depending on your OS. Asterisk Windows asterisk %localapp data %backslash beamng.drive backslash 0.31 backslash settings.json, replace 0.31 with your current beamng.drive version. Asterisk Linux asterisk /local /share /beamng.drive /0.31 settings.json, again, replace 0.31. Asterisk input maps folder asterisk located in your user folder as well. Contains .json files that define input mappings for different devices, keyboard, gamepad, etc. Each file represents a specific input profile. Asterisk vehicle configuration files, .pc files while not settings in the same sense. Vehicle configuration files store parameters specific to each vehicle variant, example suspension stiffness, engine power. These can be modified through code as well. Asterisk mission files, .mis files missions can also override certain settings or provide level-specific configurations. Asterisk memory, runtime some settings are only active during the game session and are not persisted to files. These are often manipulated directly through Lua scripts. 2. Accessing and modifying settings with Lua. beamng.drive provides a robust scripting API, application programming interface, based on Lua. This API allows you to interact with the game's engine and modify settings. Essential Lua functions and variables asterisk. Asterisk settings table asterisk a global Lua table that provides access to many persistent settings. You can read and write values within this table to modify settings stored in settings.json. It's not a direct mirror of the settings.json file, the game engine manages the synchronization. Asterisk hooks API asterisk provides hooks, functions that are called automatically at specific events, to modify the user interface. For example, you can add custom options to the settings menu. Asterisk physics API asterisk allows you to directly access and modify the physics simulation parameters. Asterisk extensions API asterisk used for creating extensions that modify existing game functionalities. Asterisk do file, asterisk executes a Lua script. Useful for loading configuration scripts. Asterisk dump, Asterisk a debugging function that prints the contents of a Lua variable to the console. Useful for examining the structure of the settings table or other game objects. Asterisk assert, asterisk checks a condition and raises an error if the condition is false. Used for error handling. Asterisk gettable keys, asterisk returns a table of keys of a table. B general workflow asterisk. 1. Locate the setting asterisk identify the specific setting you want to modify. Use the dump function or explore the settings.json file to find the correct variable name and its location in the settings hierarchy. 2. Access the setting asterisk use the settings table or other appropriate API function to access the settings value. 3. Modify the setting asterisk change the settings value to your desired value. 4. Apply the change, if necessary some settings take effect immediately, while others might require a restart of the game or a specific action to be applied, example reloading the UI. 5. Persist the change, if desired if you want the setting to persist across game sessions, you might need to save the settings explicitly using settings.save. 6. Error handling asterisk always include error handling in your scripts using assert, or call, to catch potential issues and prevent the game from crashing. 3. Practical code examples. Let's look at some practical examples of how to modify different types of settings using Lua. Example 1, changing graphics settings, resolution. Explanation asterisk. Asterisk we use settings.get to read the current width and height from the GFX/display-width and GFX/display-height locations in the settings. Asterisk we use settings.setValue to change the values. Asterisk note, some graphics settings may require a restart of the UI or graphics engine. The settings.save command ensures that the changes persist across game sessions. However, beamng often saves changes automatically so it's typically unneeded. Example 2, modifying physics settings, time step. Explanation asterisk. Asterisk this example uses the getCore function, available in certain contexts, to obtain a handle to the physics core. The physics core provides functions to access and modify simulation parameters. Asterisk the code then accesses and sets the time step using getTimeStep and setTimeStep. Asterisk important, changes to physics settings made this way are often not persistent. They are typically intended for runtime effects. You'd likely want to modify level-specific settings or vehicle.pc files for lasting changes. Example 3, modifying input bindings, changing a key. Explanation asterisk. Asterisk this example directly modifies an input mapping file, example keyboard.json. Asterisk it loads the JSON data from the file, iterates through the actions array to find the action you want to change, example break. Asterisk it clears out the old bindings and adds new key to the table. Asterisk it then saves the modified JSON back to the file. Asterisk important asterisk directly modifying input maps can be risky if done incorrectly. Always back up your input maps before making changes. beamng.drive often reloads input maps, so changes might not be immediately visible. Restarting the game is usually necessary. Example 4, creating a custom UI option, graphics setting. Explanation asterisk. Asterisk this example demonstrates how to add a custom UI element, a slider, to the graphics settings menu. Asterisk the onCustom graphics option changed function is called when the slider's value changes. Asterisk the add custom graphics option function creates the slider and adds it to the graphics settings panel. This is the trickiest part because you need to identify the correct GUI object within the beamng.drive UI. Use the UI editor, Ctrl plus F11, to inspect the UI hierarchy and find the panel where you want to add the option. The exact panel name may change with game updates. Asterisk the gehooks.add function hooks into the options dialog on tab selected event, which is triggered when a tab in the options dialog is selected. We check if the graphics tab is selected and then call on graphics settings loaded to add the custom option. 4. Important considerations and best practices. Asterisk backup your files. Asterisk before modifying any configuration files, always make a backup. This allows you to revert to the original state if something goes wrong. Asterisk use the UI editor. Asterisk the UI editor, Ctrl plus F11, is your friend when working with UI modifications. Use it to inspect the UI hierarchy and find the correct GUI objects to interact with. Asterisk error handling. Asterisk implement proper error handling in your Lua scripts using assert, or call, to catch potential issues and prevent crashes. Asterisk game updates. Asterisk beamng.drive is constantly evolving. Game updates can change the structure of configuration files, UI elements, and the Lua API. Be prepared to adapt your scripts to accommodate these changes. Asterisk read the documentation. Asterisk refer to the official beamng.drive documentation and forums for the most up-to-date information on the Lua API and settings. Asterisk test thoroughly. Asterisk test your modifications thoroughly to ensure they work as expected and do not introduce any unexpected issues. Asterisk modding etiquette. Asterisk if you're creating mods for public distribution, follow good modding practices, such as providing clear instructions, avoiding conflicts with other mods, and crediting your sources. Asterisk performance. Asterisk be mindful of the performance impact of your modifications, especially when dealing with physics settings. V. Advanced techniques. Asterisk extensions. Asterisk use extensions to create more complex and modular modifications. Extensions allow you to package your scripts and resources into a self-contained unit. Asterisk vehicle configuration files. Asterisk modify vehicle.pc files to customize vehicle behavior. You can change engine parameters, suspension settings, tire properties, and much more. Asterisk mission scripting. Asterisk use Lua scripting within missions to create custom scenarios, trigger events, and modify the game world. Asterisk event listeners. Asterisk use event listeners to respond to various game events, such as vehicle collisions, AI decisions, and user input. Asterisk threading. Asterisk for computationally intensive tasks, consider using Lua threads to avoid blocking the main game loop. 6. Common issues and troubleshooting. Asterisk settings not saving. Asterisk ensure that you're using settings.save when necessary. However, as mentioned, beamng often saves changes automatically, so this may not be needed. Check the console for error messages related to settings saving. Asterisk UI modifications not working. Asterisk double check the names of GUI objects and the structure of the UI hierarchy using the UI editor. Ensure that your code is being executed at the correct time. Asterisk physics issues. Asterisk incorrect physics settings can lead to unstable simulations or unrealistic behavior. Test your changes carefully and consult the documentation for recommended values. Asterisk script errors. Asterisk pay close attention to error messages in the console. Use debugging techniques, example dump, to identify the source of the errors. Asterisk conflicting mods. Asterisk if you're using multiple mods, they might conflict with each other. Try disabling mods one by one to isolate the source of the conflict. 7. Conclusion. Modifying beamng.drive settings with Lua provides a powerful way to customize your simulation experience. By understanding the settings hierarchy, the Lua API, and the techniques outlined in this tutorial, you can create custom scenarios, fine-tune vehicle behavior, and enhance the game's visual fidelity. Remember to back up your files, test thoroughly, and consult the documentation for the best results. Good luck, and have fun modding.